Hello, check. Alright people, I believe we are live. Welcome to Catalysis by Vedantu. If you can hear me and see me, please write yo in the chat box. You know what to do. Yes? और बताओ दोस्तों क्या चल रहा है जिंदगी में? So this is the second class of electrochemistry. The first class we've had on Thursday already. And in that class, we've discussed very basic ideas about what are cells, what are galvanic cells, what are electrolytic cells. We had the example of a Daniell cell. And then we had tried to understand a little bit about the electrochemical series. So any chemical process, okay, any chemical process can be thought of as a redox reaction. Okay, in redox reactions there's an oxidation and a reduction. So whenever you classify something as a redox reaction, you can break it apart into two halves. One half is the oxidation half, one half is the reduction half. Now, as you know, these half reactions can't happen on their own, but we want to compare these half reactions with each other so that we can figure out whether the total reaction can happen or not, whether we can make a cell or not. So what we do is we make the electrochemical series. Okay, higher value of EMF or higher value of voltage over here implies that this reaction wants to happen very easily. Okay, lower value of EMF implies that this reaction does not want to happen easily. ठीक है, ये basic idea है इसका. And all of these values are measured against one standard electrode that is called the standard hydrogen electrode. And this was all of your homework to figure out what is standard hydrogen electrode. Yes, this is the homework that I had given you. SHE, standard hydrogen electrode. So what we do is we basically create a cell of all of these different things with hydrogen. We say that hydrogen's electrode potential is 0. इसको बोल देते हैं कि इसका potential is 0. We define a standard like gravity. Yeah, we define a standard that at the ground level my potential energy will be 0. Something like that. So we define a standard that this guy has 0 EMF. So when we complete the cell and put a voltmeter, whatever is the other half, the voltage of that reaction will be equal to the EMF of the other half of the reaction. Yeah. So this is what is going on. Okay. So these values that have been written over here, my dear friends, these values, okay, these values are known as reduction potentials. Can you see that? Do you see that each and every reaction over here is capturing some electrons? And whenever you give electrons to a species, it is called reduction. So all of these values are called reduction potential values. Okay. Now, what if you want to look at oxidation potential values? Yeah. Over here, lithium plus electron is giving you, lithium positive plus electron is giving you lithium, isn't it? What if you want to see the potential value when lithium breaks apart into electron plus lithium positive? Quickly, can you tell me what will be the potential? Okay, what will be the electrode potential of this reaction? Lithium going towards lithium positive plus electron. What is going to be the voltage for this reaction? क्या होगा बताओ? What is the electrode potential for this reaction? So since this is an oxidation reaction, I can write E of oxidation. E bole to electrode potential, ox bole to oxidation. Can you quickly tell me what will be the value? Of course, the negative of this guy. Yeah. From here to here, if the voltage is minus 3.05, from here to here, voltage will be plus 3.05. This comes out to be plus 3.05 volts. Okay. Now, let us take another reaction. Let us take a reduction reaction from here. कौन सा reduction reaction ले? Let's take the reaction of chlorine. Okay. So let's take a reaction chlorine plus 2 electrons give you 2 times Cl negative. Now, what's the electrode potential for this reaction? Electrode potential of this reaction is E reduction. Yes. This is equal to how much? It's given as 1.36 volts. Yes, ये दे रखा है. Now, can these two reactions happen together? Yes or no? Can these two reactions happen together? What do I mean by these two reactions happening together? I mean that the electrons that are given out by lithium, the same electrons you feed the chlorine. Okay, this is the oxidation half of the cell, this is the reduction half of the cell. If I am trying to make a cell out of these two, do you think it is going to work? My dear friends, this particular process, this is the electrode potential, this particular process, this is the electrode potential. Total process, add up the electrode potentials. टोटल कितना आ जाएगा? टोटल में सिंपली एड अप द इलेक्ट्रोड पोटेंशियल्स, और कुछ नहीं करना, ठीक है? सो टोटल इलेक्ट्रोड पोटेंशियल विल कम आउट टू बी, isn't it? Total electrode potential will come out to be 4.41 volts. Am I right or am I wrong? Tell me. क्या ये सही है, क्या ये गलत है? सोच के देखो. This reaction when happens, yeah, electrode potential is plus 1.36 volts. This reaction when it happens, electrode potential is plus 3.05 volts. When these two reactions are happening together, total will be 4.41, isn't it? है ना जी? Now the thing is that this guy, this particular thing is known as the EMF of the cell. EMF is known as the electromotive force, and I have explained what is electromotive force in the class on Thursday. Okay, any electrical component that is generated by something non-electrical is known as electromotive force. Okay. Okay. As you're saying, electron should be same. No, not really, Achyut. So the thing is that these are just voltages. No matter how much lithium you take over here, this will be the standard voltage. So we are creating a cell with standard concentrations. Okay? Why? When I say that I am creating a cell of lithium with chlorine, I am inherently assuming, I am implicitly assuming that the concentrations I am taking are standard concentration, 1 molar concentration of both of those. Okay? So no need to worry about the concentration right now. We will worry about the quantity when we look at Nernst equation, which is something that we will come to in the end of this class. Okay? So good question, electrons should be same, etc, etc, but don't worry, धीरे धीरे अपन उस पे आ जाएंगे. ठीक है? रोहित, you should tell me what is the positive terminal, what is the negative terminal, है ना? वही डिपेंड करता है ना, what is the positive terminal, what's the negative terminal. This is oxidation, so this is going to be happening at the anode. Anode is going to be the negative terminal. This is the reduction reaction. This is going to be happening at the cathode. This is the positive terminal. Got it? As simple as that. Okay. This is the negative terminal, anode. This is the positive terminal. That is the cathode. Fine. So this is the significance of the electrochemical series. Now let me go to the next page. ये करके देखते हैं. Okay. Write the cell reaction and calculate the value of E0 cell for this particular cell that is given. What's the cell that is given? Zinc going to zinc 2 positive. There's a salt bridge in the middle. Fe2 positive going to Fe3 positive. There's a platinum electrode. What does this mean? Let's decipher this particular formula. Okay, इस formula को अपन decipher करते हैं. Let's try to break this formula down. I'll explain the meaning of each and every term to you. This is zinc. This is danda, a straight line in the middle. Then you've got zinc 2 positive. Then you've got these 2 straight lines. Okay, and then you've got Fe2 positive, comma Fe3 positive, and that is again separated by one single line, and then you've got a platinum thing written on the right hand side. My dear friends, let's try to understand what this entire thing means. Okay, this zinc is the electrode. Okay, so on one side of the container you've got a zinc electrode, then this line refers to the phase boundary. Okay, this line refers to the phase boundary. Okay, so you've got a zinc electrode that is metal, that is solid. You've got zinc 2 positive electrolyte that is aqueous, right? Then in the middle, you've got this. Okay, this basically tells you that the containers are separate now. You can think of this as the wire / salt bridge. Okay, cool. So this is the electrode. This zinc 2 positive is the electrolyte. Now on the right hand side, look at the interesting thing. Fe2 positive and Fe3 positive are kept in platinum. What is this going on? I'll explain it to you. This part is present inside the electrolyte. Okay, the electrolyte has both Fe2 positive and Fe3 positive ions, and Fe2 positive is getting converted into Fe3 positive. This entire reaction is going from left to right basically. Okay, zinc is going towards zinc 2 positive. It is giving you some electrons. Those electrons are going here, so on and so forth. ठीक है, ऐसे इसकी गाड़ी चल रही है. तो यहाँ सोचेंगे, what's going on over here? Is Fe2 positive going to Fe3 positive? Is Fe3 positive going to Fe2 positive? Think about it. Is this correct? Or is it going in this direction? What do you think? सोच के बताना. Okay. Then on the right hand side, the extreme right, you've got the platinum, which is again the electrode. सोच के देखते क्या चल रहा है. Let's carefully think about what is happening in this reaction. Okay. आराम से सोच के देखेंगे. Knowledge trends, no, I do not teach in the pro classes. Zinc is going to zinc 2 positive. It's going to give you some electrons. Use those electrons somewhere here. क्या करें? सोच के देखो. Let's try to think about it. तो दोस्तों आप करेंगे क्या अपन? First thing is zinc is going to zinc 2 positive. That is very clear. ठीक है, तो यहाँ लिख देते हैं zinc is going towards zinc 2 positive and it will be releasing 2 electrons. Yes, this is pretty simple. ये तो हो रहा है. Zinc is going to zinc 2 positive plus 2 electrons because zinc is on the left hand side, zinc 2 positive is on the right hand side. तो इन्होंने ऐसे लिख दिया. Okay, this is how they've written it. What is this process, people? What is this process? This process is a process of oxidation. This is the process of oxidation. Yes, pretty simple. And what is the electrode potential of oxidation over here? क्या होगा electrode potential? Let's think about it. देखो, what is this given? This value is E naught of zinc 2 positive to zinc minus 0.76 volts. Whenever these standard values are mentioned, they are always reduction potentials, number one. Standard values always will be mentioned as reduction potentials. ठीक है? Now over here, how to tell whether it's a reduction potential or not? Zinc 2 positive is on the left, zinc is on the right. Yeah, so this process will be reduction. It is going from zinc 2 positive towards zinc. है ना? So zinc 2 positive on the left, zinc on the right. This is your reduction reaction. So if the reduction potential is minus 0.76, what will be the oxidation potential? Oxidation potential will be plus 0.76. तो ये हो गया अपने पास. This part is clear. Now the right hand side is a little tricky. Okay, the right hand side is a little tricky because of the way it is written. देखो, you need to utilize these electrons. Okay, electrons आपको utilize करना है. Basically you have some electrons, then you have to add it to something to create something else. Can I write this? Does this make sense? Fe3 positive plus 1 electron gives you Fe2 positive. बात बनती है? I can write this, isn't it? And this is a very beautiful reduction reaction. इसको separate कर देता हूँ इधर. This is a very nice reduction reaction. And what is the electrode potential of reduction? It is already given to you. Fe3 positive when it goes to Fe2 positive, 0.77 volts. So my dear friends, this can be the oxidation half and this can be the reduction half. Over here, okay, over here it is better, okay, it is better to write it as this, separated by Fe3 positive going to Fe2 positive, and then you've got platinum. This is just a better way to write things, but even if they write it, it is not a problem, because anyway, when you write a cell, usually the left hand side is the oxidation half, the right hand side is the reduction half. Okay? Left hand side is generally the oxidation half, right hand side is generally the reduction half. So you can pretty much understand that if Fe3 positive is going to Fe2 positive only, then it is reduction. 3 से 2 जा रहे हो तभी रिडक्शन होगा ना, 2 से 3 जाके रिडक्शन तो नहीं होगा. Fine. So that's the idea. This is the way in which you should read a cell. This is the way you should read a cell, and these are the two half reactions. Okay. These are the two half reactions. This is the oxidation half. This is the reduction half. Okay. तो इनको अगर combine करके लिखना है, you can write them in a combined manner as well. I'll write that towards the end. End में लिखूंगा combine. So now assuming that we are taking standard amounts of these, बिल्कुल standard amounts अगर ले रहे हैं अपन 1 mole, 1 mole, 1 mole, 1 mole types, then what will be the total EMF? इनको ऐड करेंगे कितना आ जाएगा? What is the EMF of the cell? What's going to be the EMF of the cell? कितना आ जाएगा ये? बताओ फटाफट से. यस रोहित, फोकस ठीक नहीं है क्या? अच्छा मैं फिर से चेक कर लेता हूं दोस्त. ठीक ही था भाई ऑलमोस्ट. रोहित, कैन यू प्लीज इंक्रीज द वीडियो क्वालिटी फ्रॉम योर साइड? ठीक है. So EMF of the cell comes out to be 1.53 volts. So this cell works. If the EMF of the cell comes out to be a positive value, then that cell works. If the EMF of the cell is a negative value, then that cell doesn't work. Now, a few points of information to you guys. ये तो सब हो गया. If I want to write the complete reaction, how will I write it? I can write the complete reaction like this. Zinc plus 2 times Fe3 positive going towards zinc 2 positive plus 2 times Fe2 positive. This can be the complete reaction. Why did I do 2 times Fe positive, 2 times Fe positive? Because zinc is giving rise to 2 electrons, and 2 electrons will take 2 Fe3 positives to Fe2 positive. Yeah. So this is the complete reaction. You can write it. Now, let me just tell you something very interesting. These values that we have been using, do you notice an E naught on top of them? Whenever we write a value with this dot on top of it, ये जो छोटा सा circle बना था ना, E naught, it is called E naught. This value is basically the standard electrode potential. Okay, this is called the standard electrode potential. What does this mean? It means, okay, sorry, it means, all right, it means that when you are measuring this electrode potential, you are measuring it at standard conditions of temperature, standard conditions of pressure. You are taking 1 molar zinc 2 positive, you are taking a fixed amount of zinc. You don't need to take a fixed amount of zinc, because you know in your equilibrium reactions, if something is a solid, you don't really count its concentration. Yeah, so zinc आप जितना मर्जी लेना है ले लो, but once you take standard amounts of everything under standard conditions of temperature and pressure, okay, 1 mole of zinc 2 positive, hydrogen electrode maybe 1 mole of H positive, etc., etc. So when you take standard concentrations, then you get this standard electrode potential. And when you use standard electrode potentials to calculate the final value, this should be written as, okay, this should be written as E naught of the cell. What is E naught of the cell? This is basically standard electromotive force, standard EMF of cell under standard conditions of temperature and pressure. Yeah, generally 1 atm room temperature 25 degrees Celsius, that's taken as the standard. Over here your concentration of Fe3 positive, Fe2 positive has to be 1 molar, concentration of zinc 2 positive has to be 1 molar. Okay, okay. So all the ion concentrations need to be 1 molar, temperature and pressure need to be standard room temperature 1 atm. Then the value that is measured will be the E naught of the cell, standard EMF of the cell. With changing temperatures, with changing concentrations, of course this value changes. If I take a different amount of Fe2 positive and I take a different amount of zinc 2 positive, of course the reaction is going to give you a different EMF. So how do we go from this standard value to that non-standard value which can arise at any temperature or any concentration? That is the discovery of Nernst equation. Slowly and steadily we're going to move towards the Nernst equation. Got it? ठीक है? Fine. चलो. So ये हो रहा है. सिद्धार्थ एक रिएक्शन उल्टी हो रही है तो उसका उल्टा लिख दिया भाई. -0.76 था तो उसको उल्टा करके लिख दिया अपन ने. ठीक है? That's all. चलो. तो ये हो गया basic idea of EMF of cell, standard electrode potentials, etc., etc. Now these things generally are taught in a series of like 2-3 classes. I have tried to cover it in 15 minutes because when we learn with questions, things become a little more easy to understand. Just with one question, I was able to explain to you what 5-6 concepts. है ना? एक ही बात में. So just in one question, I was able to explain to you how to read this particular equation. Yeah, what is the oxidation half? What is the reduction half? What is the E naught? Why is it the standard value? What's the definition of the standard value? How do you reduce that and write the full chemical equation? Taught you all those ideas. Now one question I have to you. Last question from this particular page is, why am I using platinum? Why platinum? मैं यहाँ platinum क्यों use कर रहा हूँ? Why am I not using iron over here? Iron का electrode क्यों नहीं use कर रहा मैं? Why not Fe? If I want to do this reaction, why can't I use iron as the electrode? If I can't use iron, why am I using platinum over here? Think about it. What do you say? And if you have studied a little bit about standard hydrogen electrode, if you did your homework and studied about the SHE, then you would know exactly what I'm trying to talk about. बताओ. Sarvesh is saying it is non-reactive. Okay, very nice. पहला point तो ये है कि platinum is inert. Sarvesh, very nice. Sarvesh is saying that platinum doesn't react. Cool. Very nice. It's not reactive. Platinum is an inert electrode. Platinum is one of those noble metals. Yeah, that don't react very easily. The thing is that you want the reaction to happen from Fe3 positive to Fe2 positive, as simple as that. आप चाहते हैं कि आपका रिएक्शन हो जिसमें Fe3 positive Fe2 positive की तरफ जा रहा है. Now, Fe3 positive and Fe2 positive are both aqueous, isn't it? My dear friends, do you realize that for the cell to work, you need an electrode over here which is then connected to the wire? Yeah, because if you connect the wire directly over here, यहाँ पे salt bridge भी है, sort of like a short circuit situation. This can work. But again, the wire that you use will be copper. Then if copper wire can get, inside the reaction mixture, then it is possible that the copper wire starts getting oxidized or reduced. है ना? So whatever is being dipped inside the aqueous mixture should not react. All the wires that we generally use are copper wires. They are good when they have to conduct electricity. But if you put them inside a solution where a redox reaction is happening, copper can also show a redox reaction. Yeah, all the wire that you took, maybe it turns into copper 2 positive, better over. Yeah, so you don't want something that starts reacting. You want something that acts as a medium for the electron transfer. Okay? Since Fe3 positive and Fe2 positive both are aqueous in nature, none of these can act as the electrode. इनमें से तो कोई metal है नहीं ना? These are not solid, these are liquid. So you need some solid substance that does not react to act as the barrier for electrons. Yeah. On this electrode, electron exchange can take place. Yeah. Fe2 positive and Fe3 positive will come on this electrode, exchange electrons, go away. So this platinum electrode is basically just a wire that is not reacting. If you use Fe over here, if you use iron, then you know iron can also react. Yeah, iron can start getting oxidized. It may turn zinc into something else. है ना, कुछ भी हो सकता है. So you want something that is an inert electrode, okay, and it provides a platform. For electron exchange. Sorry. If other things are aqueous. Okay, other things are aqueous. So you can write this down. Alright. Platinum is basically just a fancy wire. Wire needs a electrode rakh rahe hain, it's just the extension of the wire. You can think about it. Wire can be taken as copper wire. Then you take platinum electrode so that it doesn't start reacting and still provides a platform for exchange of electrons because other things are aqueous now. Same in hydrogen electrode, right? Standard hydrogen electrode. You've got dissolved hydrogen, you've got H positive. ठीक है. Siddharth, in this entire case, Fe3 positive is going to Fe2 positive, and that is exactly what is mentioned over here. Okay, no need to worry about it. Sarvesh, we'll get to that eventually, don't worry. So Bhaiya Subramaniam is saying the wire itself can be platinum, you can do that. If you've got that much money, you can do that. Generally, platinum electrodes are very small and they are stored in the laboratory. Platinum is a very expensive metal. Okay. तो platinum की wire अगर use करने लग गए तो भाई हो गया काम. Okay. And anyway, you know why copper is better for conduction instead of any other metal. I'm pretty sure you read it. ठीक है ना जी? चलो. So this is done. Just in one question, we've covered so many significant points about the EMF. Now, let us try to figure out a relationship between Gibbs free energy and EMF of the cell. This is very interesting. Okay. Relationship between Gibbs free energy and EMF of the cell. Okay. Let's read it out step by step. Okay. Let's read it out step by step. My dear friends, first statement is the electrical work done by the cell. What is cell doing? Cell, when it's working, it is doing electrical work. It is generating some electrical power. Electrical work ho raha hai. Where is that energy coming from? My dear friends, when a reaction happens on its own, throwback time to thermodynamics. If you studied thermodynamics from me, then you understand this concept very easily, I'm pretty sure. My question to you is, whenever a chemical reaction happens, it is doing some work, isn't it? Non-expansion work. It's not expanding, it's not contracting, but it's doing some work to do the reaction. Yes. So over here in this chapter, we are focusing on those chemical reactions that give me some electromotive force, that give me some potential difference, using which I can run my batteries. Using which I can make my batteries, using which I can run my phone or my car or my calculator or my watch. Yeah. So we are concerned about chemical reactions over here, which provide me electrical work, which provide me electrical energy, isn't it? Whenever a reaction happens spontaneously, what energy is it using? Batao. Whenever a reaction happens spontaneously, whenever a reaction happens on its own, what energy storage is it using? In each and every reaction, in each and every chemical, I should say, okay, in each and every chemical system, there is an energy contained inside the system which is known as the Gibbs free energy. The system uses its Gibbs free energy to give you some meaningful work. The system uses that Gibbs free energy to do the chemical reaction. Yes. If you have studied thermodynamics with me, you understand this very easily because I've literally spent like one entire class explaining this idea mathematically as well. ठीक है, तो होता क्या है? Why do we say delta G less than 0 is a spontaneous reaction? Delta G less than 0 means the reactions, the chemicals, Gibbs free energy is reducing. It is using that Gibbs free energy to do the chemical reaction. So think of Gibbs free energy as this potential energy stored inside the system, and whenever that system does the reaction, which in this case is an electrical production, क्या कहें इसको, electrical work production, it is using its Gibbs free energy to do that work. है ना जी? Sorry. बात समझ में आई क्या हो रहा है? Gibbs free energy is the energy that is being utilized to create the electromotive force and eventually to do the electrical work done. Okay, fine. So over here electrical work is basically equal to decrease in Gibbs free energy. बात समझ में आ रही है ना? आपको क्या करना है? आपको दुनिया सुधारनी है, ठीक है? आपको दुनिया कैसे सुधारोगे? अपनी एनर्जी यूज करके. अपनी एनर्जी को बोल दो गिब्स एनर्जी. What am I saying? I'm saying if you have to improve the world, how will you improve the world? You will improve the world by doing some work using your energy. Call that energy Gibbs energy. So that Gibbs energy that you use is equal to the improvement in the world. Same thing over here. The reaction is doing electrical work. It is trying to move an electron from one place to the other. Yes. Now when that electron moves from one place to the other, that is basically equal to the decrease in the Gibbs free energy. है ना? That is equal to the decrease in the Gibbs free energy. Yeah, decrease in free energy. Delta G is equal to electrical work. Okay, very, very simple. Now, how do we calculate electrical work? This is something that you should have studied in your physics classes or in your classes earlier in 11th class. Electrical work is equal to Q times V. What is Q? Q is charge. V is what? V is the potential difference. Okay. How to calculate electrical work? Electrical work is basically charge into potential difference. How does this come out? You can do that in physics. Okay. So how are we calculating electrical work done? Charge into potential difference. Now, in our chemical reactions, redox reactions, basically what is happening? Only electrons are flowing. And since only electrons are flowing, we calculate the total charge of 1 mole of electrons. Why? Why are we trying to calculate charge of 1 mole of electrons? Because in chemistry, we deal with moles. I'll try to tell you why. Dekho. Whenever I do a redox reaction, let us say Fe2 positive is going to Fe3 positive plus an electron. Whenever I write this reaction, what do I mean? I mean that in this particular reaction, okay, in this particular oxidation reaction, I am taking 1 mole of Fe2 positive that breaks apart into 1 mole of Fe3 positive plus 1 mole of electrons. So whenever I'm dealing with chemistry, I'm always dealing with moles of electrons. Yes. In redox reactions, what is happening? Basically, electrons are going from one end of the cell to the other end of the cell. है ना? यहाँ से इलेक्ट्रॉन आया, दूसरे जगह चला गया. You know what is the potential difference between these two electrodes? That is the EMF of the cell. है ना? This is one electrode, this is the other electrode. You know the potential difference is EMF of the cell. If you can calculate what are the number of electrons being transferred from that electrode to this electrode, you can figure out the work done. है ना? Because number of electrons into potential difference will be the work done. And that number of electrons we are trying to calculate in moles. ठीक है, चलो. So let us now try to figure out the total charge of 1 mole of electrons. ठीक है, तो बड़ी सिंपल सी बात है ये तो. Charge on 1 mole of electrons is equal to Avogadro's number, that is 6.022 into 10 to the power 23 into charge of 1 electron in coulombs, 1.6 into 10 to the power minus 19 coulombs. When you multiply this, you get a very interesting number. You get a number that is approximately equal to 96500 coulombs. 96500 coulombs is also called 1 Faraday. This is something that you have to remember. Okay. Erica, Saurav sir is already doing that. ठीक है. Saurav sir is going to do that very soon. Inorganic chemistry is going to be taken by Saurav sir. He is an expert at that. I am not that good at inorganic chemistry. ठीक है जी. So what have we done over here? We've basically calculated the charge on 1 mole of electrons. Charge of 1 electron is 1.6 into 10 to the power minus 19 coulombs. 1 mole is 6.022 into 10 to the power 23. Multiply those numbers, you will get 96500 coulombs. 96,500 coulombs approximately. That is also called 1 Faraday. Faraday is also a unit of charge. 1 Faraday is the charge carried by 1 mole of electrons. In coulombs, that same charge is equal to 96500. Please remember this value. Shubhiksa is asking about the difference between standard temperature and normal temperature and pressure. Standard is generally taken at 0 degree, normal is generally taken at 25 degree. बस उतना ही difference है. थोड़ा सा फर्क. Okay, cool. So 1 Faraday is equal to charge on 1 mole of electrons. So my dear friends, my question to you now, ये लिख लिया आपने? This is something that you've written. तो अब मैं एक empty page create करता हूँ, so that before showing you any formula, we'll do something. Let this go away. So let's think of a cell. This is the salt bridge. I'm just making the salt bridge look like this. Don't worry about it, okay? इसमें I know that EMF of the cell is, let's say, equal to 2 volts. ठीक है? EMF of the cell is equal to 2 volts. Now, my dear friends, what will be the electrical work done over here? Electrical work done will be equal to charge into voltage. Charge will basically be equal to the number of electrons, है ना? Number of electrons into 1.6 into 10 to the power minus 19 coulombs into voltage. I can write this in a different manner. How can I write it? I can write this as moles of electrons into 96500 into voltage. Yes. लिख सकता हूं ना मैं? Number of electrons into 1.6 into 10 to the power minus 19. Rather write it as number of moles of electrons into charge on 1 mole of electrons. 96500 coulombs. Sorry. So this is 96500 coulombs into voltage. Fine. This particular equation, this particular formula, which is very obvious, can be written as, okay, can be written as N. 96500 coulombs is 1 Faraday. N is basically the number of moles of electrons. V is just voltage, which for the cell we write as E. E is basically the EMF of the cell. So electrical work done by any cell is equal to N into F into E. Okay. Now for this particular cell, let us think that it is a Daniell cell. What is a Daniell cell? Daniell cell is when zinc goes to zinc 2 positive, plus 2 electrons, and these 2 electrons are taken by copper 2 positive to go back to copper, है ना? So for this particular cell we need to take 2 electrons as the value. Okay, why? Because when I do the complete reaction, what will be the complete reaction? Zinc plus copper 2 positive goes to zinc 2 positive plus copper. In this entire process, if I take 1 mole of zinc, 1 mole of copper, 1 mole of zinc 2 positive and 1 mole of copper, then my dear friends, in this entire reaction 2 electrons are being exchanged, है ना? समझ रहे हो? 1 zinc, 1 copper, 1 zinc, 1 copper, 2 electrons are exchanged. If I have 1 mole zinc, 1 mole copper, 1 mole zinc, 1 mole copper, then 2 moles of electrons are exchanged, है ना? Zinc gives away 2 moles of electrons, that is taken by the copper. So over here N will be equal to 2. समझ रहे हो बात को? I am saying the EMF of the cell is 2 volt. Just assume, okay, just assume this value 1.51 volts होती है, ठीक है, भाड़ में जाए. We're just assuming this as 2. N is 2 because the electron exchange is of 2 electrons per mole. तो यहाँ पे क्या आ जाएगा? N will be 2. Faraday's 96500. EMF कितना दे रखा है? 2 volts. This is the electrical work done in this particular cell. Okay, this is the electrical work done in this particular cell. Now I'm going to erase everything from here. If you need more time on this page, I will request you to pause the video. चलो, तो यहां पे मेरे पास आ गया that the electrical work done is equal to N into F into E, and this is equal to change in Gibbs energy. Isn't it? This is equal to change in Gibbs energy, delta G. But my dear friends, do you realize we need both the sides to have the same sign? Now delta G, if a reaction is happening on its own, yeah, मान लो reaction खुद से हो गया, delta G is happening on its own, delta G will be a negative value, है ना? Reaction happening on its own, delta G will be a negative value. On the other hand, since the reaction is happening on its own, it is doing positive work. Do you understand? You are pushing a container. The work done on the container basically is positive, but for you, you are losing your energy. My dear friends, since this quantity is negative, this quantity is positive, but I want to have an equal to sign over here. Can I do this? यहाँ पे एक नेगेटिव साइन ऐड कर दो, just to make the mathematics equal. Better still, I should say delta G is equal to NFE. But since I want the mathematics to be a little more precise, this is what I write. Delta is equal to minus NFE. Cool. Jitendra, what happened, bro? Jitendra, there is a separate video that I have made on how to clear backlogs. I hope you understand that if you spam this video with questions on how to clear backlogs, I won't be able to do that because I'm teaching a specific topic over here. Please focus on what is going on. That's the first thing that you need to do to cover backlogs. There is a separate video that I've made on how to cover backlogs. Please go and watch that. Okay. So. And Jitendra, let me tell you, breakups in your age are very common. Happens with almost each and every person. That is not something that you can use as as a demotivating factor. It happens to everyone, being very honest. Okay, चलो ठीक है, ये सबको समझ आ गया होगा. So let me open this page for you. Let n moles of electrons be there, Q equals to NF. Let EMF be the EMF of the cell be E. What is the electrical work? NFE, and that is equal to minus of delta G. Delta is equal to minus NFE cell. This is exactly what we've understood on the previous page. This particular equation is very, very, very important. And if I'm taking standard conditions of temperature, pressure, I'm taking 1 mole concentration all over the place, yeah? I'm taking 1 mole of the electrode, I'm taking 1 molar concentration of the solution, etc., etc. So if I'm doing this under standard conditions, I can write this as delta G naught is equal to minus NF E naught of cell. Okay, this is for standard cases. When your cell is working under standard temperature and pressure, when you've got 1 molar electrodes, when you've 1 molar electrolytes, when you've got 1 mole of electrodes, etc., etc. ठीक है, चलो. Trishank asks, is it necessary to watch live class? No bro, you can watch it later as well as a recording. ठीक है, चलो. तो ये हो गया आपका बहुत ही important equation. Now the next equation that I'm going to tell you is something that you can look for the derivation, but it's not important. ठीक है, तो ये बात तो काफी simple है. Delta G when it's negative, reaction is spontaneous. E cell when it's positive, it's spontaneous. We already understood, right? When the question was being solved, I told you that when the EMF of the cell comes out to be positive, the cell will work. That is how the cell will give us some energy to work. Yeah, imagine that the battery that you get from the market says minus 1.5 volts. You won't use that battery, right? It says plus 1.5 volts, so you can use that plus 1.5 volts to move the electrons and make your calculators work, make your remote controllers work, etc. ठीक है, तो चलो नेगेटिव पॉजिटिव ये चमकता ही है सबको. डेल्टा जी नेगेटिव स्पॉन्टेनियस, डेल्टा जी पॉजिटिव नॉन स्पॉन्टेनियस, ई सेल इज नेगेटिव नॉन स्पॉन्टेनियस, डेल्टा जी इज इक्वल टू 0. That means the reaction is at equilibrium. Basics from chemical equilibrium chapter. If delta G is 0, reaction is at equilibrium. Standard condition के लिए delta G naught equals to NFE naught cell. Next equation that I'm going to show you. Okay. The equation that I'm going to show you right now is very interesting. Okay. काफी interesting सा equation है. Do you remember this equation? Delta G is equal to delta G naught plus RT ln Q. ये reaction देखा है किसी ने कभी? Have you guys seen this particular reaction? So what I'll do is I'll tell you how to look at the derivation for this guy. If you haven't seen this reaction already, just give me one moment. Trying to open the derivation of this guy. Just a second, okay? My internet sometimes, my laptop sometimes doesn't work properly. Okay, so how do you derive this equation? It's a little long process. You don't need to learn the derivation, but this is a web page. The link is over here. I will share this link in the chat box with you guys. Don't worry. Just give me 2 minutes. I'll put this link in the comments down below as well. Okay? So this is the link. You can call this a self-study link. So if you open this link, this is the web page that will open in front of you. Free energy and the equilibrium constant, chemistry libre texts. Okay. So if you scroll down, they have shown you exactly how to, derive this particular equation. काफी लंबा सा है derivation. If you don't know how to derive it, you can look at it over here. Derivation is not important at all. तो यहाँ से कर आके आ जाएगा. Delta G is equal to RT ln K. ये delta G is equal to delta G naught plus RT ln Q. Q is the reaction quotient. ठीक है. So let me just give you guys this link. ये मैं लिंक कॉपी कर रहा हूँ. I will put this on YouTube. Just give me 2 minutes. I'm going to share this link with you. You can open this link later. No need to open it right now. Okay. बाद में खोल सकते हो लिंक को आराम से. ठीक है, I have put the link in the chat box as well 4 times, and I will put this link in the comments down below as well. Cool. So the very first comment on this video will be of this particular link. ठीक है, चलो. Coming back here, this is an equation that you need to remember. This is an equation that you need to remember. इस equation को याद रखने का है. This is the self study for its derivation if you want. ठीक है. Now, another thing that we just learnt was delta G is equal to minus NFE. Let's just try to combine both of these equations together. Can I write minus NFE is equal to minus NFE naught? This is EMF at any point of time. This is standard EMF. है ना जी? This is EMF of the cell at any point of time, any concentration, any temperature, any condition. This is under standard conditions, yeah? Standard temperature, standard pressure, 1 mole electrodes, 1 molar electrolyte solutions, standard conditions, plus RT ln Q. Let's just rewrite this equation a little. Let's multiply all the sides with a minus sign. Minus से इसको multiply करेंगे, so this becomes plus, this becomes plus, this guy becomes minus, है ना? Now, let's divide this entire equation with n. n से divide कर देते हैं पूरी की पूरी उठा के. Yes. Let's divide both equations, both sides of the equation with f. Faraday से भी divide कर देते हैं. तो यहां से Faraday भी कट गया, Faraday भी कट गया. Do you see where we are going? What we can write from here is EMF of the cell at any point of time is related to the standard EMF of the cell with this particular relationship. E is equal to E naught minus RT by NF ln of Q. What is Q? Q is your reaction quotient. I'm going to erase this, and I'm going to show you an example of the reaction quotient as well. Let's erase this. Let's write the reaction between zinc and copper once again. Yeah, this is solid, this is aqueous, this is aqueous, this is solid. My dear friends, reaction quotient कैसे लिखूंगा मैं? Activities of products divided by activities of reactants. What is reaction quotient? K equilibrium का भाई. Brother of K equilibrium is your reaction quotient. So, in your K equilibrium equation, in your reaction quotient equation, do you write solids? No. Solid activities are always 1. You need to worry about only the aqueous part. So, over here Q will come out to be zinc 2 positive divided by copper 2 positive. So, the standard condition is when this guy is 1 molar, this guy is 1 molar. Okay? When this guy is 1 mole, this guy is 1 moles per liter. Okay? Capital M बोले तो molar, 1 mole per liter. So when both of these are 1 mole per liter, that is standard situation. At any other situation, you can calculate the EMF using the standard EMF and this particular formula. ये formula use कर सकते हो. ठीक है जी? Fine. So my dear friends, this equation that we have derived over here, this equation is very fondly known as the Nernst equation. Okay, आज की class was dedicated to understanding and deriving the Nernst equation. This is literally the most important part of electrochemistry chapter, and tomorrow's class, which is going to be at 8:30 p.m. yet again, we are going to devote that entire class towards the understanding and application of the Nernst equation. So today's class was coming from EMF to Nernst equation. Tomorrow's class is going to be all about the applications of the Nernst equation. We'll dive deeper into it, and we'll see a bunch of questions which we can solve using the Nernst equation. Okay? Tushar, you can ask the doubts in the chat box as well if I am able to answer them well and good. Otherwise, you can ask your doubts in the comments down below after the class is over. Okay, so after the class is over, just refresh the live stream once again and you will be greeted with a comment section. Just leave a comment over there and I will try to get back to you. Otherwise, someone from our channel, basically some of the students of this channel, will help you understand your doubt. ठीक है? ये देखिए सिंह जिसका थर्मो वीक है वो नहीं समझ पाएगा थोड़ा. इफ योर thermodynamics is weaker, then this will turn into a memory based chapter for you instead of an understanding based chapter. Now what you can do is just memorize this equation. No one is asking you about the derivation. Maybe they will ask one question about the concept behind this equation, but most of the questions, especially in NEET and JEE mains, will be calculation centric based on this equation, which is something that you can solve even if you don't understand the derivation behind this particular equation. Gayatri, we've already done a marathon on P block video, marathon on P block elements video. You can watch that. It's there in the one short series playlist. Okay. Chalo, badhiya. Janvi Singh, if EMF is negative, does it mean that the reaction would happen in the opposite direction? Pretty much, Janvi. That's exactly what it means. Cell ulta chalega basically aapka. Chalo, nice. This is basically what we have to do for today's class. The self-study link, I had given it to you in the comment section. It's also somewhere in the chat box. ठीक है? हाँ तुषार, जहाँ पे भी हो आप comments दे सकते हो. Either I will help you or someone out of your friends will help you. ठीक है? Jasleen, that's going to be very difficult for me to do. Equilibrium is weak. I have done chemical equilibrium in just 3 classes. Please watch those. Okay. GRB book is very good. Yes, you can use that. Aditya, yo, what's up, man? ठीक है, बढ़िया. तो चलो दोस्तों, that's it from my side for today's class. I hope you enjoyed. So what did we do today? We understood the basic idea behind what is EMF. Yeah. And we saw the electrochemical series. We understood how the electrochemical series is derived, and then we used the ideas of the electrochemical series, which are the electrode potentials, to calculate the standard EMF of a certain cell, which was a zinc and iron cell. Yeah, in that zinc iron cell, we've understood how to read the cell notation. Yeah, you've got the oxidation half first, then the salt bridge, then the reduction half. Yeah, and sometimes when you've got different inert electrodes, you mention them as well. So we understood how to read a particular cell notation. We've understood how to figure out what is the reduction half, what is the oxidation half. We've understood what are standard electrode potentials, and we've also understood what is standard EMF in that particular question. Then after that question, we came to understand that all the energy that a reaction is utilizing, it is going into doing the electrical work. That gave rise to the very simple equation delta G is equal to minus NFE. Using that equation and combining it with the equation which will be derived over here, we come to the Nernst equation. That is what we've done in today's class. Tomorrow at 8:30, yaad rakhna, tomorrow at 8:30, we are gonna continue. So, in case you enjoyed this class, please make sure you hit that thumbs up button. I know things might get a little bit complicated in physical chemistry, but as soon as we start doing questions, things will become much more simple. So wait for tomorrow's class. If you enjoyed this one, please make sure you hit that thumbs up button. In case you want to enroll with us at Vedantu, on our patented platform, where lots of good master teachers are teaching, where lots of content is given out, question banks, study materials, regular tests every weekend. If you want to be a proper coaching student at Vedantu, then you can look at the links in the description box down below. Lots of good courses running for you guys. There's a crash course running for JEE 2021 as well. People, that's it from my side. If you've got anything more to say, leave a comment down below later. I'll take your leave. Bye bye. Take care.